Now here we'll discuss the basics of the Mohr circle. Already we have discussed the basics of Mohr circle, where we have studied the importance of Mohr circle and the advantage of Mohr circle, and how to plot the normal stresses value, that is sigma x and sigma y, in a Mohr circle, and the location of oblique plane we have discussed in the earlier lecture. And we have discussed the stress to length conversion, how we can convert and plot and or draw the Mohr circle, construct the Mohr circle. Now here today we'll discuss about how to locate the principal stresses, where how to locate this major principal stress, major principal stress, that is sigma 1, how to locate. Similarly, how to locate the minor principal stress, sigma 2, in the Mohr circle. Similarly, the principal plane, how to locate the principal plane in a Mohr circle. Then maximum shear stress, how to locate the maximum shear stress, that is a tau max in Mohr circle. Then the plane of maximum shear stress, plane of maximum shear stress. Then the sigma theta and tau theta value, how to find out this value in any oblique plane, in oblique plane. Then how to find out the normal stress on tau max plane, that already we have discussed in analytical method. Now all those things, how can we find out from the or with the help of this Mohr circle? The resultant stress on oblique plane, resultant stress on oblique plane, and the obliquity, that is we denote as a phi. So how do we construct all those things and find out with the help of this Mohr circle? So one by one we'll discuss all those things. First I'll discuss the principal stress, how to locate the principal stress. Principal stresses, that is nothing but the major principal stress and the minor principal stress, sigma 1, sigma 2. So for that, already we have discussed in the earlier lecture. We have taken this component, small element of the any component we have taken, and we had discussed on that. Similar I draw here. So this is the sigma x, sigma y, sigma x, sigma y, and it was the any oblique plane theta. So our sign convention was the tensile in nature we take positive, compressive we take negative, clockwise movement we take positive in a shear stress, anti-clockwise motion of the shear stress we take this negative. So this is the our sign convention, and based on that we plot this Mohr circle. So this is the suppose coordinate of Mohr circle, where it is we take the plus plus, and this minus plus, minus minus, and this plus minus, and based on the questions and the coordinate of this element we can shift this system here or here. If it is this if we can plot this side means this area we can take more and this area will take less. Similarly, if the element is given such that we have to take or draw this Mohr circle in this area, so we have to take this area more and this area very less, we can shift this, so no problem. Now if you see the first important thing is that we have to take coordinate system, already we have discussed. So coordinate system for this is sigma x positive, tau is negative, so we can draw like this. So already we have drawn in the previous lecture. Similar, I can draw this tau everywhere the tau value is same, so magnitude is same means the length of this will be same. So this was the construction. So if I take this radius and draw this circle like this, so this is suppose a circle. So where will be the location of the principal stress? So all the plane, which is plane already I have given A, B, C, I have given this name, and suppose this oblique plane I am giving this M and N, I am giving MN plane. Okay, so this is the MN plane, this oblique plane is a MN plane. So this is A, B plane, X plane, and BC is a Y plane, and this oblique plane is a MN plane. So where would be the location of the principal stress? As we know, the principal stress is a stress which act on a principal plane where the shear stress is 0. So that point we have to consider in a mind. This is the normal stress plus sigma n, and here it is normal stress minus sigma n. This is plus tau, this is negative tau. So here you can see that the principal stress, the stress which act on a principal plane where the shear stress value is 0. So this is the line, this is the line, this is called the normal stress, and this is the line, and all the circumference of this Mohr circle denoted the plane. So this is denoted the plane. Now here you can see that this sigma n, this line, this sigma n, I'm not writing here, sigma n which is positive and tau is 0 here. So this is the line where only the normal stress act, no shear stress act in this line. So that's why in this line and the circumference of the Mohr circle which denote the plane where we locate our principal plane. So here at this is the point. So again, so this is the point, green, I'm just, this is the point which shows the plane of the principal stress, and this is the length, it is called this value is sigma 1. So this is the sigma 1 and this is the length of sigma 1. So it is the principal stress, means you have to take the scale, and from that scale, from this is our reference line, and everything you have to take from the reference line, and you have to put scale here to here, measure this length. If you measure this length, you can convert length into the stress value. Already we have discussed that you can take 1 megapascal as a 1 mm. So whatever the stress value will be given for the sigma x, sigma y, you can convert in such a manner. So our 100 megapascal can be converted as a 100 mm or 10 centimeter, or based on your convenience you can take this value and you can measure from here to here. This is the whatever the length will be there, that you can convert in the megapascal. So this would be the sigma 1. So this is called the measure principal stress, because sigma 1 the value is greater than, that's why we take this plane where the shear stress is 0 called the measure principal stress, and here at this point where the shear stress is 0, and apart from that everywhere if you go the shear stress value will be there. So only this is the point where the shear stress is 0. So this is called the minor shear stress, and sigma 2 I denote. So this value is, this is for the measure principal stress, and this is the minor principal stress. So you can take from here to here scale and measure this principal stress. So this is the measure and this is the minor principal stress. This is our center C. Now next one, the principal plane. How? Now we'll see the location of principal plane. Principal plane, where we see the angle of measure angle of major principal plane, and this is the alpha 1, which is nothing but the angle of minor principal plane. So for that, again we draw this Mohr circle, where this is our center, this was the AC plane, and suppose if I draw, this is our AB plane, it's AC plane, this is the here to here, this is our origin, and here to here this is sigma x, and here to here this is sigma y. So, and this is our principal plane sigma 1, and this is our principal minor principal, this is our major principal stress, that is a sigma 1, and this is the minor principal stress. So I denote this as, already I have denoted this D and E. Now where will be the location of the principal plane? So that principal plane we have to take from the reference line only. This is our reference plane, and this is our reference line. This is very important. This is our reference line, and from that reference line we take the angle of the major principal plane and angle of minor principal plane. So this is our major principal stress sigma 1, this is the line of this. So if we go in this way, this is called 2 alpha. If you go anti-clockwise, this is anti-clockwise. So you can go from this manner also, anti-clockwise, or you can go from here to here also. This is the major principal stress, so this will be this will be the clockwise direction of alpha. So we denote in the Mohr circle 2 alpha. So this is the angle of the major principal plane. So we can also show in this way the clockwise sense or anti-clockwise sense, but the value will be, you have to always write the sense clockwise or anti-clockwise. If you see the clockwise, that this is the, suppose this plane AB, I am denoting this A, so ACD, angle ACD divided by 2 is nothing but the angle of the major principal plane. This value you have to write. So whatever you will measure here in this Mohr circle, you have to take half value to give the answer of this angle of major principal plane, because every angle will be doubled in the Mohr circle. So that you have to consider in your mind. Next, anti-clockwise, that you have to also, so this is the anti-clockwise, so that also you have to write angle ACD divided by 2. So this is also alpha. So that also you have to write. This is very important. Clockwise or anti-clockwise manner you have to write always. Similarly, the angle of the minor principal plane. Now to show this angle of minor principal plane from this reference line you have to show. So if you go like this way, so this is the minor principal stress line. So here up to here you have to take the angle. So here this is the clockwise sense. This is the clockwise sense, so this will be the 2 alpha 1. So here you can write angle ACE. Angle ACE divided by 2 is nothing but the alpha 1, and this is the clockwise. This is the clockwise. Or you can also move anti-clockwise. So you can see here anti-clockwise, if you have to go, you take this reference line and you move from here to here. This is nothing but, if you go anti-clockwise, this will be 2 alpha 1. So that also you can write anti-clockwise. any sense, if you want to go from this reference line, you have to mention, this is very important, means you have to mention the every sense, that if you go the clockwise or anti-clockwise, you have to mention in the answer sheet. This is very important. Now we'll see the maximum shear stress, maximum shear stress, that is tau max, and plane of maximum shear stress. So again I draw this Mohr circle. So this was your Mohr circle. This is center C, and it was AC plane, BC plane. This was so here. Now from here to here it was sigma y, here to here sigma 2, similarly here to this is nothing but is sigma x, and from here to this is sigma 1. Now so already we have given name, this is the name E I am giving, and this is D. And suppose we know this maximum shear stress, the maximum shear stress will be at the maximum point of this circle. So this is actually, this is the vertical is a tau, it shows the shear stress. So from this point if you go here, so this is the actual point where the maximum shear stress will be there. So this is the point, and from here to here this will be the tau max, this will be tau max. So through this scale you have to measure from this to this, so you will get the tau max value. So tau max value will be in the top and bottom both side, in the positive plane and negative plane. So here this tau max from here to here, it is also called this tau max plane. So this is, you have to measure from this to this, this will be the tau max, but this tau max will be, the downward side will be minus tau max. So this will be minus tau max, this will be minus tau max, and this will be the positive tau max, positive tau max. So this is all about the maximum shear stress. You have to measure through the scale from this to this. This is the length here to here, which shows the tau max plane, tau max value in this positive and this negative plane. Both sides the tau max value will be there. Anyone you have to write. And if you measure from this origin, this is the origin, and from here to here, if you measure this, it will show the normal stress on tau max plane. So this will show normal stress on tau max plane. Already we have discussed these things in the analytical method, that how we can calculate this normal stress, which we have denoted in the previous lecture of the analytical method by this sigma prime. So sigma prime you can directly measure from this to this length. So this will be the normal stress on tau max plane, and from here to here it will be tau max. Now the next question is, where the plane of maximum shear stress? So plane of maximum shear stress you can draw. This is our reference plane, because this is our reference plane and this is our reference line on this plane, reference line on this reference plane. And from here to, if you move this side, this anti-clockwise, so this will be 2 beta 1 anti-clockwise So this will be the plane of maximum shear stress. So sense may be this clockwise, that we can take positive, or it may be like this also. It can go here to tau max plane. This is clockwise to beta 1, and you can also write this. So the clockwise you can write, so angle, I just denote this AC, this AB, sorry, this is AB and this is BC. So AB I can denote by A, and it can return angle AC. I'm giving this name F, and this is G, suppose. So ACF by 2 equal to beta 1. So every angle in this Mohr circle will be doubled. So actually if you have to calculate to write the answer, so you have to go in this manner. Take this angle, divide by 2 and give the value of beta 1. So this beta 1 is nothing but the plane of maximum shear stress. Or anti-clockwise you have to mention. If you mention only the clockwise, then you have to write this is the value that you have measured from the clockwise direction, or if you have measured from anti-clockwise direction, that you have to write. Means anything else, if you measure whether clockwise or anti-clockwise, that must be important that you have to mention this in the answer sheet. So this will be angle ACF by 2 is nothing but beta 1. Similarly here you can see this is the negative tau line. So if you go this from this reference line to this is nothing but anti-clockwise. So this will give 2 beta 2. So this anti-clockwise is nothing but the angle A, C and G by 2 gives beta 2. Or if you go clockwise, then if you measure clockwise, then you have to write this by mentioning this, the anti-clockwise, this anti-clockwise. So this was the clockwise, earlier was a clockwise, and this is the anti-clockwise. So if you go in this manner from reference line to the tau max, negative tau max plane, this you have to measure. This anti-clockwise is nothing but ACG by 2 is beta 2. So this sense is very important. To measure this sense is very important. If you go this clockwise here to here, this is clockwise, you have to measure this beta 2. Or if you are measuring this anti-clockwise to beta 2, you have to show this anti-clockwise. So this is the very important when you showing this the plane of maximum shear stress on the Mohr circle. Anyone you can show, whether you show through this clockwise or anti-clockwise, anyone, but this is very important that you have to write this clockwise or anti-clockwise term, so that we can know from where you have measured this angle. Oblique plane. Same way I can draw this Mohr circle. So this was this plane AB, AC, center C. So and we have seen in our element, so it was a sigma x, and this is the tau value. So this was the sigma y, and this is the tau value. So this is the tau value sigma y, and this is the tau value. So you can see here the angle theta which form in this element rotate from this vertical clockwise. Clockwise we are taking positive. So this is the reference plane, and from this reference plane, this is our reference plane. This is the reference line, we can say that the reference line which is in this, which is lying in this plane, reference plane. So from this it is clockwise movement is there of this oblique plane mn. So we can draw this 2 theta here, and I am giving this mn plane. So this is the our oblique plane, this is our oblique plane. Here is oblique plane which is 2 theta in this Mohr circle. So from this is our reference line 0 0, and from this reference line this is our plane. So we can draw a perpendicular line from this plane into this normal stress axis. So this is the perpendicular 90 degree. So if you draw these things, so this height shows tau theta, and this length from the origin to here, it is sigma theta. So likewise you can find out this, you can measure through the scale. So whatever the length will be there, you can convert into the stress. So sigma theta from this origin to this oblique plane you can find out, and tau theta in oblique plane you can find out to draw this perpendicular line onto this normal stress. Okay, now how you can find out the resultant? As we have known, which we have seen in this analytical method, that this resultant sigma r at oblique plane will be nothing but this tau theta value. So here in this Mohr circle, directly from this origin to, we can draw the line which join this to mn plane, origin to mn plane. So here this length is gives the resultant stress. So this length origin I am giving o mn length gives to resultant stress. Means if you want to find out the resultant stress value, so you have to measure from this, and the angle which is here, this angle is nothing but the obliquity phi, that is the obliquity phi. So this is the obliquity phi, and this is the resultant stress at oblique plane. The length will give the stress value for the resultant of this oblique on this oblique plane, and this angle if you measure, this is nothing but the obliquity phi, that will take as a phi. So here we have discussed about the principal stresses, principal plane, maximum shear stress on tau max plane, the shear stresses on tau max plane, sigma theta, tau theta value we have discussed in oblique plane. Then the normal, how to find out the normal stress? You can find out the normal